Okay, here we are with Lesson 15, Graphing Solutions to Inequalities. So the materials you're going to need for this lesson is a ruler or some sort of straight edge to draw your number lines. Alright, let's take a look at exercise 1. Two identical cars need to fit into a small garage. The opening is 23 feet 6 inches wide, and there must be at least 3 feet 6 inches of clearance between the cars and between the edges of the garage. How wide can the cars be? We're going to start by drawing a diagram of the problem. So here's what you should have. If you have a garage and it is 23 feet 6 inches, well, you can write that as 23.5 feet. Then if it's 3 feet 6 inches between the car and the garage, and between the two cars, and between the car and garage on the other side, if you want to write that in feet, that would be 3.5 feet for each one of these. Since the total width of the garage is not more than 23.5 feet, it is represented as less than or equal to 23.5. According to the drawing, there are three lengths of 3.5 feet, which is 3 times 3.5, or 10.5. The identical cars have an unknown width. Let W represent the width, therefore it is 2W. So based on this information, let's write the equation. We would have 2 times W plus 10.5 is less than or equal to 23.5. So solve the equation to find the width of the car. And this is what it should look like. If you start with 2W plus 10.5 is less than or equal to 23.5, we're going to start by subtracting 10.5 from both sides. That leaves us with 2 times W is less than or equal to 13, and multiplying by the reciprocal of 2, which is 1/2, we would get half of 13, which is 6.5. So the width of the cars can be less than or equal to 6.5 feet. So describe numerically how to find the width of each car. You should have something that looks like this. To find the width of each car, we subtract the minimum amount of space needed on either side of each car and in between the cars from the total length. That is represented by the 10.5. Altogether, the amount of space needed was 3 times 3.5, which was 10.5 feet. Then we divided the result. 23.5 minus 10.5 is 13, which is what we got right here. And we divided it by 2 since there are 2 cars. So dividing by 2 is the same as multiplying by 1/2. The answer should be no more than 13 divided by 2, which is 16.5 feet. So why is an inequality used instead of an equation? Well, since the minimum amount of space between the cars and each side of the garage is at least 3 feet 6 inches, which is 3.5 feet, the space could be larger than 3 feet 6 inches. If so, then the width of the cars would be smaller. Since the width in between the cars and on the sides is not exactly 3 feet 6 inches, and it could be more, then there are many possible car widths. An inequality will give all possible car widths. So what happens if the width of each car is less than 6.5 feet? Well, then the amount of space between the cars and on either side of the car and the garage is more than 3 feet 6 inches. So what happens if the width of each car is exactly 6.5 feet? Well, then the amount of space between the cars and on either side of the car and the garage is exactly 3 feet 6 inches. So what happens if the width of each car is more than 6.5 feet? Well, then the amount of space between the cars and on either side of the car and the garage is less than 3 feet 6 inches. So how many possible car widths are there? Well, there's an infinite amount of possible widths. So what assumption is being made? Well, the assumption made is that the width of the car is greater than 0 feet. The graph illustrates all possible values less than 6.5 feet, but in the context of the problem, we know that the width of the car must be greater than 0 feet. Since we have determined there is an infinite amount, how can we illustrate this on a number line? Well, if we start with a number line, and if we partition it into halves, since we're dealing with halves, that will make it easier. So if we have 6.5 feet is the equals, and we know that it can be less than 6.5, then what we do is we draw a solid line with an arrow direction pointing to less than 6.5 to show that it goes to 0 feet. So what if 6.5 feet could not be a width, but all other possible measures less than 6.5 feet could be a possible width? How would the graph be different? Well, we would start with our number line again, but this time instead of a closed circle, we would have an open circle to represent the fact that the value cannot be 6.5 feet. Then we would make a solid line going to the left again to 0 to indicate all the other infinite possibilities that could be present, except again 6.5 feet is not one of the solutions. All right, let's take a look at an example. So a local car dealership is trying to sell all the cars that are on the lot. Currently there are 525 cars on the lot, and the general manager estimates that they will consistently sell 50 cars per week. Estimate how many weeks it will take for the number of cars on the lot to be less than 75. So write an inequality that can be used to find the number of full weeks, which we will label as W, that it will take for the number of cars to be less than 75. Since W is the number of full or complete weeks, W equals 1 means that at the end of week 1. So what is the inequality that represents this problem? Well, we would have 525 minus 50 times W is less than 75. So solve the inequality and graph it. Well, we would start off by subtracting 525 from 75, which will give us a negative number. But that also leaves us on the left-hand side of the inequality a negative 50 times W to show that we are taking away 50 cars per week. In order to isolate W, we would multiply by the reciprocal of negative 50, which is negative 1 over 50. Notice what happens when we multiply by a negative number or divide by a negative number. Notice how our inequality changes. So W is going to be greater than 9 weeks. And to graph that, we would just make a number line based with maybe some numbers to the left of 9 and a couple of numbers to the right of 9. Since the answer cannot be 9 weeks, we would use an open circle, and because its W is greater than 9, we would highlight every infinite possibility from 9 greater than using our arrow vector. So interpret the solution in the context of the problem. Well, the dealership can sell 50 cars per week for more than 9 weeks to have less than 75 cars remaining on the lot. Let's verify that solution. Well, if W is equal to 9, 525 minus 50 times 9 is going to be less than 75. 525 minus 450 is 75, but again 75 is not less than 75, so this is false. So what if W is 10? Well, we plug it in. 50 times 10 is 500. 525 minus 500 is 25, and 25 is less than 75, so this is true. So explain why 50W was subtracted from 525 and why the inequality less than was used. Well, subtraction is used because the cars are being sold. Therefore, the inventory is being reduced. The less than inequality was used because the question asked for the number of cars remaining to be less than 75. In one of these steps, the inequality was reversed. Why did this occur? Well, the inequality in the problem reversed because both sides were multiplied by a negative number. All right, let's take a look at exercise 2. Complete exercise 2, then check your answer by continuing the video. Make sure you look at the previous examples to help you out. Okay, you should be done with exercise 2. So go ahead and check your work with the work presented here. If there's something that doesn't make sense to you, make sure you make a note and bring it to class. Alright, you have some additional exercises. Complete these exercises, then check your answer by continuing the video. Alright, you should be done with the additional exercises. Here is exercise 3 and 4. Again, go ahead and check the answers with yours. If you have any questions, please make a note and bring it to class. All right, moving on to example 5, or exercise 5. All right, once you have checked your answers, let's go ahead and wrap this up. So why do we use rays when graphing the solutions of an inequality on a number line? Well, when graphing the solution of an inequality on a number line, how do you determine what type of circle to use, open or closed? And when graphing the solution of an inequality on a number line, how do you determine the direction of the arrow? All right, we'll see you in class.